All right.
Time check.
I got like 5.
Got like 5 minutes left. Let's go here. Okay.
Are we going conceptual for this whole period?
Really excited.
I wanted to do I wanted to do one like calculation type problem. Alright, here we go. She's out of here.
She did that before. She just stood up and I was like, what are you doing? She's like, I don't know.
Saw that.
Just delirious right now.
Yeah.
Lauren, when did you go to bed, Lauren?
Well, she woke up at like 4.
Well, she always takes a bit. All right. Arm of a crane at a construction site, 15 meters long, makes a 20-degree angle with the ground. The maximum load that the crane can lift is limited by the amount of torque produced at the base of the crane. So, let's start off. Ground. And potato. It's actually a pea pod. So,
Is that a tank?
what's this problem about?
Crane.
It's about a crane.
That's clearly a tank.
I mean, come on.
That's an elephant.
No, it's a big barrel.
Squidward. There we go.
He's got a claw.
It's a crane, so, you know. Anyway,
Well, malfunction in that crane.
Pretty good tree.
How does a crane balance like that?
hey, I just want you to know.
Yeah, how?
Hey, I just want you to know, critiquing my drawing puts you over the time limit, okay? I just want you to know that.
Sure.
Well, if the buzzer goes off, I'm still finishing this problem, so.
There's a buzzer.
Oh, there's a buzzer.
Is it going to go on?
Alright, come on, let's finish.
Okay, so, crane, blah, blah. So it says, what is the maximum torque that the crane can tolerate if it can lift a load of 4,000 kilograms? It says 4 times 10 to the third, it's 4,000 kilograms. Okay, good so far? So, part A. What's part A asking us about?
Maximum.
Okay, so part A is asking us about torque. Okay. What did they give us for torque with part A?
The distance.
Okay, they gave us a distance, right?
The angle.
The crane is 15 meters long. Okay? So that's going to be our lever arm.
All right.
It gave us an angle, right, Luke?
Yeah.
But it said that that angle was 20 degrees off of the ground, right?
So what does that mean?
Well, that's what I want us to figure out, okay?
Yes.
So, well, I will.
Okay.
The force here, the force that's creating the torque on the crane is coming from where?
Top.
What do you think?
No, where the elephant nose is. Right there.
Here, right? This is the force, right? Technically, what force is it? It's gravity acting on this load right here, right? So this is an F of G force, and it's equal to M times G. What did it tell us that the M was in this problem?
4,000 kilograms.
The M is 4,000 kilograms. So 4,000 kilograms times 9.81, okay? And that will get us our force. Lauren, should you calculate it out?
39240.
39240. That's just going to be newtons. Okay?
Woo!
And that's going to be our force down here, right? That's the force that's being applied to the crane. 39240. Okay? Now we said that our formula for torque looks like this. F times D times sine of theta, right? I keep throwing that in there. Times sine of theta, right? But we said that theta was the angle between what and what? Is it 20 in this case? No, it's not this angle that we're worried about. It's this angle that we're worried about, right? So what does that angle have to be? Hopefully we can do this without doing calculation. It has to be 70, okay? Because if we look at gravity going straight down, that's always going to make a 90-degree angle there. Okay? So now we have theta of 70 degrees. So we plug in things we know, make sure we're in degree mode, if you're using your calculator. D is going to be 15, and then sine of 70. Lauren, did you calculate it out?
Yes.
What'd you get?
553103080.
5531.
03.
03.
Oh, zero.
That's right. Okay. And we'll sig dig that up to 5.53 times 10 to the 5th. Okay. And unit-wise, that's going to be newtons times meters. What?
Maximum.
That's the maximum torque that that crane can handle. Okay. Good there?
Yeah, it's gonna be.
Sorry we missed this, but
Well, two
Wait,
variables
wait here.
together.
I turned the speakers off, so when the speakers are off and the microphone's on, you get like feedback sometimes. So. All right. I know. I lied.
You.
A liar. I'm a liar. Apologize.
Little responsible.
All right. Part B. What is the mass to maximum load the crane can lift if the angle is increased to 40? So, for part B, right, now we're looking for a mass, right?
Yeah.
We know the torque, right? What did we figure out in the last problem?
5.53 times 7.
That's the maximum torque. So we're going to keep that number, 5.53 times 10 to the 5th. Okay? They told us that the angle is going to be increased now to what?
I didn't see it.
60.
60.
40.
Well, the angle is being increased to 40, right? So this is going to go up to 40 degrees. But did we say, is that the angle that we're worried about?
No, so
No.
then it's 50.
This one over here would then need to be 50. Okay? That's the angle between the force and the lever arm. So theta is 50. Okay? Did the length of the crane change?
No.
Nope. So that D is still 15 meters. Okay. So now we plug that back in. Formula F D sine theta. Okay. They gave us a torque. The force we said really was what kind of a force? It's gravity force, right? So we can go here, force, this is going to be M times 9.81, right? D is still going to be 15, and we're talking about sine of 50.
Let's do it. Then we're done.
You got that?
Yeah. 4,906. You do the what? Divided by all that.
9.81 times 15 times sine of 50. I'll do it.
You don't catch it. It's not.
Who would?
Oh,
And then you divide by 9.81.
no, you add all of it up on the right side and then you plug in that number and do the right by answer.
What?
Plug everything on the right side. Get a value.
Wait, you got it. It doesn't matter.
And then if we sig dig it up, 4,910. That's going to be kilograms because that's mass. So, real quick, just before we leave, I'll post the rest of the answers to that problem set online, so you can check those out if you want to do them sometime before we meet again